Hello, and welcome to this video lecture on how to solve problem number 3. I've had a request that there's some misunderstanding or not enough understanding of how all the numbers and results work when you're doing regression analysis inside of a spreadsheet. So I'm going to go over this and hopefully everybody will get all the points for this particular problem. So in problem number 3 of chapter 7, it's asking you for Jensen Tire and Auto is deciding whether to purchase a maintenance contract for its new computer wheel alignment and balancing machine. Managers feel that maintenance expense should be related to usage, and they collected the following information on weekly usage hours. That would be this column, and the annual maintenance expense in hundreds of dollars. So that's what this column is showing. So part A says develop a scatter chart with weekly usage hours as independent variable. So independent variable, they're saying this is your X. So that means this one has to be your Y. Okay? So we're going to just graph this. We literally, hold on one second. Just literally highlight everything, including the labels at the top. We come over here under Home, go to Insert tab, Recommended Charts. It gives you the scatter chart. Okay, so fairly easy to do. Looks just like the one I just created. Sometimes though, when you're laying out your data, you don't know which is X or which is Y. All right, and so if the data is listed this here way, what you could do is you could literally go in here and type in a big number. So this changed this one to 100, so this must have been the X column. I'll hit Control Z, that brings it back. And so now I can make it look nice by putting in the titles, type in something here, type in something here. And what you'll end up with then, as a scatter chart, is something like this one. Okay? So weekly hours, expenses in hundreds of dollars. Step B says use the data to develop an estimated regression equation that could be used to predict the annual maintenance expense for a given number of hours of weekly usage. What is the estimated regression model? So what you want to do here is literally highlight everything again, go to your Data tab, and then what you're going to select under your Data tab is you're going to select Data Analysis, and then you're going to do Regression Analysis. I've already input those values, so B1 to B11 is going to be my Y range, and anything else, A1 to A11, will be my X range. I want to include labels so I'll know what I'm looking at. The confidence level, I don't want to force the line through the 0 point. I'm going to put it on a new worksheet, and I don't want any of these residual plots yet, so I'll hit OK. And so then what you're given is this output. And let's go ahead and just make sure everything is wide enough for us. So I'm going to go to Home tab, and you don't see it on here, but I'm going to the Format area, Auto Column Fit, and we can see that we have the intercept, the weekly usage hours. So again, let me do all of that. And now we have our output for this regression analysis. So here's our R square. It's a measure of fit. How well does weekly usage hours predict annual expense? Well, it goes 85.61%. The intercept, that's the intercept for the y-axis, that's our B sub 0. The weekly usage hours, this is the coefficient for that, so that's B sub 1. It automatically calculates a t-statistic for you, but the important one is this p-value. So if this is B sub 0, this is B sub 1. If you had any other x values you put into the equation, they would be listed here. These p-values, the probability values, if they're less than your alpha, and alpha could be 0.05, 0.01. Here, if we're looking at 0.05, this p-value is less than 0.05, so it's significant. So is this one, it's significant. We also see that our 95% confidence interval ranges from these values, and it doesn't cross 0. So we can say that they are significant. Step C says test whether each of the regression parameters B sub 0, B sub 1 is equal to 0 at the 0.05 level of significance. What are the correct interpretations of the estimated regression parameters? Are these interpretations reasonable? So we can go back and add in our residuals. I'm going to go to insert, go to data, data analysis, choose regression again, and now I'll plot the residuals. I'll click OK. And it looks like I'm going to have to change my Y range. Doesn't include labels. And my X range doesn't include labels. I'm going to check residuals, residual plots. I had to make sure that they both contain the same number, A2 to A11, B2 to B11. Click OK. And there you see our residual plot. There's only 10 observations, so that's hard to make any, I guess, recommendations as to whether it's violated the conditions or not, but it doesn't look like it's different from 0 here. They're scattered fairly randomly. Also note that I had to remove those labels, so now we just have an intercept here and our variable here, x variable, so that's beta 1. So for beta 1, the p-value is 0.0001, and since that's less than 0.05, it has a level of significance, we would reject the hypothesis that B1 is equal to 0. And we would go ahead and conclude then that there is a relationship between weekly usage and annual maintenance expense. And the best estimate is that 1 hour increase in weekly usage, if we put in an X of 1, is $95.34 in annual maintenance. So you see how that came about. So that's what I would be looking for a part C answer. If we look at B sub 0, we would then assume that there is an X of 0, meaning the weekly usage is 0. The annual maintenance expense would be Move that out 2 more, it will be $1,052.80 if you round up slightly. And this is the estimate. Doesn't make much sense, but we want to test whether the hypothesis is that B0, this one, is equal to 0. And this is sort of meaningless because none of our y points are close to 0. Right? So that doesn't make much sense. But if we look at this lower and upper bounds, it doesn't cross 0, so it is significant. Part D says, how much of the variation in the sample values of annual maintenance expense does the model you estimated in Part B explain? Well, all we have to do is come up here and look at R squared, and R squared is 85.61%. So that would be your Part D answer. And so that explains 86% of the variation of the values of your annual maintenance expense. Part E says, if the maintenance contract costs $3,000 per year, would you recommend purchasing it? Why or why not? Okay, Part E. If the maintenance contract costs $3,000 per year, would you recommend purchasing it? Why or why not? Okay, so one of the first things you probably have to do here is calculate the average weekly hours. So the average weekly hours is 25.3. We know that our model is listed here. I just brought that over from the other page. And beta 0 is 10.528, beta 1 is 9.534. What would be the average maintenance expense that we would think we would incur? And so all I did was take and put in this number in for X. So this number times this value plus B0 gives me that. Now, if you're a purist, then maybe you want to write it out just like the equation, plus D17 times B14. So we give it 34.64 in hundreds of dollars, or 3,464. Okay? So now it says, okay, what happens if we want to spend 30,000? Well, 3,000 per year in hundreds is written as 30. Okay? So if this is confusing to you, you might want to just convert everything to regular numbers and don't worry about whether they're in hundreds or not. But we're going to leave it as 30. So the question is if 30 is equal to 10.528 plus 9.9534 times X, what is X? So X is going to tell me the weekly usage hours that it takes to use up this 30 or $3,000 per year. So we need to solve for X. So to do that, we would need to subtract 10.528 from both sides. So we would say equals this minus this. If I subtract that from this equation, then I'm left with 0.9534 times X. And then if I solve for X, I just need to divide both sides by 0.934. So I would say equals this divided by that, and I'm left with X. So X is equal to 20.42237 hours. And so that's the break-even point on that $3,000. If I think I'm going to exceed that, then I should buy the contract. I think looking at all my numbers, the average number is 25.3. I think I'm going to exceed that because it's greater than 20.43. So for part E, I should buy the contract, and that's the reason why. And that's how you solve that particular problem. I hope it helps.